Oscillators. Pierce oscillator. Frequency is determined by crystals. So I showed you guys a crystal last week. Crystals are usually small wafer of quartz with precise dimensions. They have a piezoelectric effect. Does anybody know what a piezoelectric effect is?
Where you hit it.
You hit it. Yeah, so when you take your lighter and it doesn't have the striker that you roll, you just push the button and it goes click. Something's hitting that crystal and creating electrical of enough spark to light your propane on fire that's in our butane. So that's a piezoelectric. So crystals are usually a small wafer of quartz with precise dimensions, and they have a piezoelectric effect, and the crystal deforms mechanically when voltage is applied. So you can hit it and get a voltage out, or you can put voltage in and you get a vibration. At a specific frequency, signal is generated when the crystal is deformed by the electric voltage. Okay, LC operator. What's L?
Inductor.
Inductor. And what's C?
Capacitor.
Capacitor. So we have an inductor capacitor, right? C. There's an inductor, and there's there's a capacitor, two of them. So if it's two capacitors, there's two C's in Colpitts oscillator. That's how I remembered it for the test. Hartley's the other one. It has one C, and there is one C in Hartley oscillator, and two in Colpitts oscillator. Okay? Don't worry about the inductors. So remember it for the question, for the test, two C's in Colpitts oscillator, two C's. One C in Hartley oscillator, one C. So if you get a question about that, that's how you remember those two. But that's what they look like. They got a transistor, they got one or two inductors, one or two capacitors, and a resistor. Okay. Frequency is determined by the values of the inductor and the capacitor, or L and C. And it's often called a tank circuit because it stores energy. Okay, there's a variable frequency oscillator, or VFO. Now that's a great big box.
That's going back a ways.
You can look at the color and basically say, oh, that was great-grandpa's or grandpa's. That little guy there, that's analog dial, and this is the one you watch in the old World War II movies where they're going, yeah, oh hey, how you doing? Are you there? Okay, what it does is it makes either the L or the C adjustable, and it's usually the C. L is inductor, C is capacitor. So you make the inductor or the capacitor adjustable, usually the capacitor, and that will change the frequency. You used to do it with an analog dial, and now almost I think everything is a digital LCD screen now. It's not as stable, and it's used to tune the radio to different frequencies. Variable frequency oscillator, VFO, is direct digital synthesis, DDS. Its typical application is as a high stability variable frequency oscillator in a transceiver, direct digital synthesis. This is where the little computer does all the math and spits out the frequency that you want. Variable frequency with the stability of a crystal oscillator. So it's digital, and it's just as good as a crystal. But because it's digital, it's not going to be susceptible to temperature changes, humidity changes, and age and all of that. Well, it might be susceptible to age and spiders. But this is the way everything's going. Okay, it can be controlled by software. The dual VFO is some radios have two of them. Common use of the dual VFO feature on transceiver is to transmit on one frequency and listen on another. So I can transmit on the upper frequency because there's an upper and a lower. And I can transmit on the frequency that's in the top window and listen on the frequency in the lower window. And then that splits up our conversation into two halves. And unless they got our frequency pair, they can only hear one half of the conversation. Or if I'm talking to through a satellite, I go up on 2 meter and I listen in on 4 meter, or I can cross band. There's all kinds of things you can do with a dual VFO. Mixers. A mixer circuit combines two frequencies. Oh, here we go. This is the part that blew my mind. F1 and F2, frequency 1 and frequency 2, and produces their sum and their difference as its output. So it's F1 plus F2, that would be the sum. You got F1, you got F2, you got F1 plus F2, plus you have the difference between F1 and F2. So we have 4 different things. Used to change the frequency of a signal. Input and output frequencies need not be related in any way, but those aren't yellow. Only that part F1 and F2 mixer circuit combines two frequencies and produces a sum and their difference as its output. Mixing is also known as heterodyning. Mixing is heterodyning. So it's kind of like a homogeneous, just it's heterodyning. Mathematically multiplies two frequencies together, generating four output frequencies. Okay, so you got F1, F2, the sum of F1 and F2, and the difference between F1 and F2, four separate frequencies. Now, with those four separate frequencies, we can apply a bunch of stupid math with a computer or an analog system and come up with whatever frequency we want. Oh, there we go. F1 times F2 is F1 plus F2, F1 minus F2, and the original 2. Operation of a mixer is similar to operation of detectors and modulators. Subsequent circuits select desired signal and make use of it. So you just apply some math and get the one you want. Multipliers. An amplifier stage that creates a multiple or harmonic of the input frequency with output circuit tuned to the desired harmonic. Multiplier creates a multiple or harmonic of the input frequency. You have a Class C amplifier. That's what that is. Used in VHF, UHF transmitters to generate a harmonic of a signal at a low frequency and then multiply it to reach the desired frequency. Modulators, circuit that adds the information to a carrier signal, because to modulate, that's how we get the information we want to send, right? As the amplitude, what else might it be? The frequency, maybe? What about the phase? And amplitude was first generated by varying the power supply voltage to the output circuit of a CW transmitter. And as voltage varies, the amplitude of the output signal's envelope follows along. But none of that was yellow, so don't worry about it. Advantages of single sideband. Transmitter power is used more effectively, and that's why we like to use sideband. In an AM signal, half of the power is in the carrier. So this has, so you got 100 watts, this carrier has 50 watts of it. And what's that carrier do? Nothing. It's wasted. Well, you got 50 watts left and it's split between these two sides. So each side gets 25 watts. Well, if my 100 watt radio is putting out 40 watts AM, or a single sideband, I went from 25 to 40. I'm still doing better, more than twice the power. Make sense? Does everybody understand that? In AM, half of the remaining power is in each of the two sidebands, or just sidebands carry the same information. So in AM, 100% of the available power is used to transmit the information. Because we don't want to burn up our radio, the 100 watt radio generally doesn't put out 100 watts in AM, in sideband. In single sideband, only 25% of transmitter power is used. So if I got 100 watts going out, if it's AM, that's only going to have 25 watts on each side though. Single sideband uses half the bandwidth because we're only using this 3 or that 3. We're not using the whole 6. A balanced modulator produces double sideband modulated RF. So double sideband modulated RF. Frequency and phase modulated. Frequency modulation, or FM, the carrier frequency deviates in proportion to the amplitude of the audio modulating signal. Your voice going into the microphone and then creating a difference that can be read. In phase modulation, the carrier frequency deviates in proportion to both the amplitude and the frequency of the modulating signal. No yellow, don't stress too much about it, that's just how they work. By changing the audio frequency response of the modulator, an FM modulator can be used to generate PM and vice versa. Both FM and PM sound similar on the air. The only difference in frequency is in frequency response of the audio. Both FM and PM can be demodulated with the same circuitry, and the design of modulator circuit determines whether FM or PM. So this circuit going in. FM is modulation applied to the oscillator circuit, and in PM the modulation is applied to an amplifier stage following the oscillator. Okay, phase modulation. A reactance modulator connected to a transmitter RF amplifier stage is used to create phase modulation. That's your question. Reactance modulator connected to a transmitter RF amplifier. So reactance modulator and an RF amplifier for phase modulation. When modulation of the signal occurs, the phase of the carrier will change. So you got the 90 degrees, right? Phase modulation. It's going to be bouncing around. The average frequency will not be changed. If a circuit that combines data or voice with an RF signal is called a modulator, then a circuit that separates them must be a demodulator. You guys are all going to get that question, right? General term that applies to different types of circuits. Each type of modulation can be demodulated by several different methods. Detectors, one category of the modulator, converts a modulated signal directly to a data or voice signal. So it's called a detector, is a demodulator. It's for AM signals. The simplest type is an envelope detector. Produces an output voltage that is a reproduction of the modulated signal's envelope. Product detectors. Detectors for CW and single sideband need to reproduce the signal's frequencies, not just their amplitude. A product detector detects CW and single sideband signals by combining a signal to frequency of the modulated signal's RF carrier with the modulated signal itself. Product detector detects CW and SSB signals. It's used in a single sideband receiver to extract the modulated signal. Are these batteries dead now? Frequency discriminators. Also just discriminator. Recovers information from an FM signal in an FM receiver. Translates the variation of the FM signal's frequency back to the original signal used to modulate the RF carrier. And a transverter. These used to be kind of popular, weren't they, Steve?
Yeah.
And not so much anymore. Transverters are used instead of a mixer to convert a transceiver to operate on a band other than it was designed for. So a band. So I've got a 2-meter radio right here, and if I have a 6-meter transverter that's 2 meters to 6, I can plug it in and it'll convert that radio's output that's intended for 2 meters so that it goes out on 6. That's a transverter. Low power transmitter signals on one band are shifted to the new output frequency, then amplified for transmission. The transmit receive switch. If the station antenna is shared between the transmitter and the receiver, which it generally is, the transmit receive switch allows the antenna to be switched to the transmitter when sending and to the receiver when receiving. In a transceiver, this TR switch is inside the unit and requires no attention by the operator. Simple CW transmitter block diagram. So a CW, you got a circulator, an oscillator, a driver. You got a telegraph key that turns it on and off, and a power amplifier going out to the antenna. That's as simple as you can make it. Actually, you could just have a battery, a spark, a wire, a switch, and a spark plug. They're going to come looking for you. Super heterodyne. So heterodyning is the what of signals? Mixing.
Mixing.
Super heterodyne, or super mixing them. So we got an oscillator, a mixer, intermediate, I'm sorry, going the wrong way here. Beat frequency oscillator goes up to a product detector. Let's see, this receiver, that's why. So the signal comes in here, a billionth of a volt hits this, hits a mixer. The oscillator is applied to the mixer. The product of the mixer and the oscillators working together puts out an intermediate frequency amplifier, which then goes to a product detector that is working with a beat frequency oscillator that then spits out the audio through an amplifier. Clear as mud, right?
Yep.
Mixer in this circuit shifts the incoming signal to an intermediate frequency. So the mixer is using this oscillator and bumps it up to intermediate frequency. So a mixer in a super heterodyne shifts the incoming signal to an intermediate frequency. That's the question. The oscillator generates a signal of a desired frequency. So this is a set frequency being applied to that mixer. Selectivity and sensitivity. So we have these two radios. We got a Kenwood and a Baofeng. Kenwood's made in Japan, and this is made in China. Okay? Probably a little difference in quality, you think? Maybe? Probably. Although some of the Japanese brand radios are now made in China. Selectivity and sensitivity. The receiver's sensitivity determines its ability to detect weak signals. So if I'm sensitive, I can pick up that weaker signal. That radio is not as sensitive as that Kenwood. That one is not as sensitive as that Kenwood. It might be more sensitive than my Baofeng, it might not. We don't know. But how much you can pick up a weak signal is sensitivity. Higher sensitivity is the ability to detect a weaker signal. A preamplifier can be used between the antenna and the receiver to increase sensitivity, so that billionth of a volt gets jacked up to 5 billionths of a volt, or whatever it is. But a preamp can be used between, and some radios have a preamplifier built in, and you can turn it on or off. It's normal and 2 preamplifiers on my 7300, just push a button. Selectivity allows the receiver to retrieve just the desired signal in the presence of unwanted signals. So, got a bunch of noise, and here's the signal I want to hear, and that Baofeng may pick up all of that noise. And that may pick up less of that noise, and that one will zero in on better. I don't know how well, but better. It's more selective. Selectivity and sensitivity. Higher selectivity is proper receiver operation even with strong signals present on nearby frequencies. Receiver sensitivity affects input amplifier gain, demodulator stage bandwidth, and the input amplifier noise figure. That's the question. So, all right. Questions. What is the function of a transceiver's PTT input? Switches transceiver from receive to transmit when grounded. There you go. What type of amateur station simultaneously retransmits the signal of another amateur station on a different channel or channel? Wow, I didn't get finished with the question. You got a Charlie already. So while I'm reading the question, you're reading all the answers, right? Somebody said, Charlie, repeater station. That is correct. What device converts the RF input and output of a transceiver to another band?
Charlie.
Wow. Transverter. Which of the following describe? If any of these questions, somebody's like, oh, wait a minute, what? Raise your hand or say speak up so that we can explain it to you. In case you misunderstood what we were teaching earlier or we haven't covered it yet. Which of the following? Charlie, is it? Yes, it's Charlie. What's the question? Which of the following describes combining speech with an RF carrier signal? Modulation, anytime we put something on a carrier. Where is an RF preamplifier installed? RF preamp.
Alpha.
Between the antenna and the receiver? That is correct. What frequency range is occupied by a 3 kilohertz lower sideband signal when the displayed carrier frequency is set to 7.178 megahertz? Okay, draw this out. That's the carrier. That's at 7.178, and it is lower sideband, so it's going to be 7.178 is the top and lower. So 3.
Drop it 3 kilohertz.
Yes, drop it 3 kilohertz. So what do we got?
Charlie. 7.175.
7.175 is correct. Everybody understand that one? What frequency range is occupied by a 3 kilohertz upper sideband signal with the displayed carrier set to 14347? 14347 plus 3 kilohertz. So?
Bravo.
Okay, and could it be Charlie or Delta? Can't, right? Because we got to start at 347. So it's 3 to 6. Oh, wait. 347 to 350. My bad. What is the frequency above which a low-pass filter's output power is less than half the input power? Frequency above which a low-pass filter's output. Cutoff is correct. The bandwidth of a band pass filter is measured between what 2 frequencies?
Alpha.
I hate that question, but that's the one they want you to answer. What term specifies a filter's attenuation inside its pass band? So if this is the part it's passing, what's the attenuation inside where it's passing? I got an alpha. Anybody else? Insertion loss. What term specifies a filter's maximum ability to reject signals outside of its pass band? I got 2 deltas. I hear only 2 people answering. Is everybody else getting this? No problem, you guys are answering, hey, you know.
I'm a good guesser.
You're a good guesser? The correct answer is that you're a good teacher.
Oh.
Come on, get with it. Which of the following are basic components of a sine wave oscillator? Sine wave oscillator.
Bravo.
Multiplier and a mixer, I've heard of Bravo.
Delta.
Delta, filter and an amplifier operating in a feedback loop.
Oh, I didn't see the loop.
Okay, so Bravo or Delta have been selected. Anybody else? Okay, Delta, defend your answer.
I think I read it last night while I was studying.
I think? Okay, well you thought right.
There we go. Oh, dude,
It's
It
Delta.
had an F in it.
What's that?
It had the letter F in it.
Oh, I had the letter
The
F.
answer did, yeah, but I couldn't.
Okay. Filter and amplifier in a feedback loop is a sine wave oscillator. Basic components of it. What determines the frequency of an LC oscillator?
Charlie.
The inductance and capacitance in the tank circuit. Which of the following is a typical application for a direct digital synthesizer? A DDS or direct digital synthesizer offers what? It is not Delta, it is not Charlie. You're down to Alpha and Bravo.
Alpha.
I got an Alpha now. Okay, the direct digital synthesizer is the same high stability and variable frequency as compared to a crystal. Remember that part? The crystal, and then we replace it with a direct digital synthesizer. High stability and variable frequency. Which of the following is characteristic of a direct digital synthesizer? Oh, there's the answer that I was thinking of. So we should all get this one, right?
Yes.
I just said it, sort of. Variable frequency with the stability of a crystal. Direct digital synthesizer. So that was a tech and a general, I believe, question. What emission is produced by a reactance modulator connected to a transmitter RF amplifier station? Have we heard of multiplex modulation yet?
No,
Delta.
Have we heard of pulse modulation yet?
no.
Have we heard of phase and amplitude modulation?
Yeah.
We have, so it's one of those. Now I got, somebody said Bravo, and it's Bravo. You got to read better?
I have a history degree and I still can't read.
You have a history degree?
I have an honors in history.
And honors.
Oh,
You
yeah.
did the extra
You
work.
get to a great position in the unemployment line.
Go to YouTube and check out the history guy.
Yes.
Oh, you know him? Yeah. Which mixer input is varied or tuned to convert signals of different frequencies to an intermediate frequency?
Charlie.
So you got the antenna and the feed line comes into the mixer, and what goes into the mixer besides that? The local oscillator goes into the mixer. What combination of a mixer's local oscillator, LO, and RF input frequencies is found in the output?
Charlie.
Everybody agree? Charlie? That's correct. What is another term for the mixing of two RF signals? Hopefully I've stressed that enough. Heterodyning. Alpha. What is a stage in a VHF FM transmitter that generates a harmonic of a lower frequency signal to reach the desired operating frequency?
Alpha.
A stage in an FM transmitter that generates a harmonic. So is generating mixing?
Yep.
Are we sure? Generating is mixing? It's a multiplier. Multiplier. Mixers take inputs. Okay. What stage generates a harmonic? That's the way to remember this one. So it multiplies it. It comes out with something else. Which term describes the ability of a receiver to detect the presence of a signal? The ability to detect is Bravo. Sensitivity. What is a transceiver?
Alpha.
It's not delta? No, it's alpha. It's alpha. It's alpha. Which of the following is used to convert a radio signal from one frequency to another?
Bravo.
Frequencies, not bands. Frequencies. phase splitter won't do it, an inverter flips it over, and an amplifier just makes it louder. So it's a mixer. Mixer. Which term describes the ability of a receiver to discriminate between multiple signals? It's the opposite of sensitivity, right? Selectivity. What is the name of a circuit that generates a signal at a specific frequency?
Delta.
I got a delta. Anybody else? Filters don't generate signals, right? Modulators don't generate a signal, they impart data. So A and B are out and C's out. Is the only possible answer is D, delta. Any questions?
Are we done? You said it.
That was a question.
You are not done!
You expected something else?